Hello, Prof. Can you provide examples of recent or ongoing final year projects that students have undertaken under you?
Okay, for this current sessions, I think there is the transition period between the 3.5 to 4-year program. Therefore, the number of students are very limited. But if you ask me for the last 3 years, I could say that the philosophy of training FYP falls under two domains. One is to train those who are really keen to explore physics and go beyond uh, for advanced studies in physics. So the topics for students who are keen to pursue their research at advanced degree, we give them topics that are contemporary, current, such as quantum information. So we had a string of students, 3 or 4 students had worked in the area of quantum information, namely quantum walk, the quantum version of classical random walk. And these models are used for quantum search engine, quantum communication, quantum cryptography. These are the 3 areas that we give some emphasis because of their importance. And at the same time, I think the students also are interested to explore this field, because this is what often mentioned in the media, the impact of quantum science. For students who are interested to explore topics outside physics, and they are not the die-hard fan of physics, but we say that if you're trained in physics, you can go places as long as you have that open mind, want to use the method of physics, the tools and techniques that you learn in physics for topics like in social science. So we had students working on finance. In fact, we call finance, that is PHYNANCE, or econophysics. And student finds that interesting, because you can see that social systems can be also subjected to models from physics. And we had students working on smart farming, but not to say they become farmers, but technologies are being employed in all the sectors, including precision farming. So you need sensors, you need to do data analysis, forecasting growth of the plant growth. So we are introducing physics students to areas where on a first look you may think it's nothing to do with physics, but we want to demonstrate that having trained in physics, you can go places. You can go into high-tech farming that involves a lot of technology. You can also go into the finance, and yeah, you can also explore any other areas that you want. So students come to me for asking for FYP topics after they have gone through the statistical physics course, because in statistical physics we introduce students to systems that are not necessarily physics based. So they also explore environment as part of a physical system, the ecology, and so on.
How do students typically initiate contact with you to express interest in conducting an FYP?
Okay, I think you need to have some background knowledge about the topic that you want to do. And I use statistical physics, my course statistical physics and mechanics, as a kind of opportunity to tell the students how I approach research. And the examples that we include in the class are often coming from what's happening at the time. For example, if you have COVID, and then we look at how does the virus spread. So you have a viral spreading model. So from there you introduce the students to areas that one can subject that system to a theoretical physics approach or computational approach. So this is one way where the student knows what we are doing. Of course, we have a website. I do not know whether students go to the website these days, but I think we should do more in terms of promoting the importance of theoretical physics. Partly because it is an area where you can apply all kind of methods, and you are not being limited by the availability of experimental setups. So as long as you can apply the mathematical model and you can do some computational simulations, I think you can be part of the exploration.
Okay. What kind of medium would you want them to contact you through?
Of course, they can email because that makes things formal. Um, and the way we run FYPs, is quite different from the experience I had before in other universities, where lecturers will be asked to list down at least maybe 2 or 3 topics, and then the students, and this will be published on the notice board, so that everybody can see, and then they can go and pick up a topic and approach the lecturers to ask about the topic. And I think now they do it via online. There's a Google sheet that lecturers will submit their FYP topics, so the students will get the chance to select the topic. Most often, I would say that people like to. I do not see this as a kind of an issue, but students like to do things that are has been studied before by other seniors, or it's quite the topics are related to another student's a topic that have been done as a FYP before, and in that sense there is I see that there is no sense of exploration. It's almost like following the path. Whereas topics in theoretical physics, first thing we would like to go is where there is no path, and you search for the path, or sometimes you make the path. And that's why the topics that we introduce sometimes can be off track, that people do not want to take because they say this is I have never heard such a thing, or physics can be applied to such a system. But then again, those who seek adventure will come. So we are not trying to go for the mass market topics. I think in theoretical physics, if your heart is hooked to it, you will follow. I think that's important. What you want to do, and what kind of trail you want to go, and then you will just just follow that trail or that lead, and you will discover something.
So it's obvious that passion plays quite a big role in your field of study, correct? So what kind of advice would you offer to students who are interested in pursuing your research?
Okay. In my group, or personally in my own training, history has played an important role. In the sense, like, I like to study and dig into the background of any topic, and then to find who's who in the field, and how does this topic come into being, and you can see the real drama behind why such a topic was explored or introduced to in the knowledge field. And in that sense, I think that should be a certain element of humanity. You have to find why people explore this topic, and then dig into the historical background to that topic, and that will bring into a sort of like a cult. You want to follow. I'm actually I would say I'm a devotee of Boltzmann's research philosophy. He could be seen as one of the first theoretical physicists of the 17th, 18th century. And if you follow his view of things, he broke that that dogmatic perception of physics, that physics is positivism, meaning that only things that you can experience and measure is real. Anything that you cannot measure is not relevant to physics. And now we know quantum mechanics, not everything you can measure, and you still believe in it. And we have to thank Boltzmann for that. And and then when you do a background research, and then you realize, there are a lot of exciting anecdotes about researchers or scientists, and they are also being inspired by the predecessors, their teachers. It's almost like carrying a baton, from one generation to another generation. So my former supervisor uh, was trained in a very good institution, and he was exposed even to Nobel laureates, as part of his training, and then he passed this, the sort of like anecdotes and inspiration, and I hope I can continue that to my, my students in the class. Hopefully, some of them will continue this journey of exploring physics, as a part of devotion in search of knowledge, and perhaps the secret of the physical universe.
Okay. Thank you so much, Professor, for those very wise words. So thank you again, and we hope you the best.
Okay, thank you very much.
Okay.